Hey y'all, welcome back to this series. This episode we're going to be fixing up our character controller so that we can move in any direction and look in any direction too. We're doing mouse input, so let's jump right into it. Now, mouse input is generally acquired in a slightly different method from other inputs. We're going to be watching for input events and process them as they happen, as opposed to the polling method we're using for movement. Event systems are reactive, where polling methods are proactive. So if nothing happens for the inputs, an event system will simply not do anything, but a polling system will need to continuously check to make sure that nothing has happened. And so for getting inputs in Godot, we're going to override a function. We're going to override input. You can use unhandled input as well, but I prefer to use input because that way I can guarantee I'm getting the inputs I want. Unhandled input will technically run faster, but you have to be very careful about what elements are going to consume the event. And as you can see, event has a prefix of an @ symbol. That actually doesn't do anything. That's just because event is a keyword in C#. And so personally, I don't like having the @ symbol to start. It's kind of difficult to type, and so I'll actually change this to just an E, because I know what it is. It's an input event. It's right there, and we're in the input method. And so what we're going to do is we're going to say if E is an input event mouse motion. And as you can see, that is a special type of input event that is specifically emitted when the mouse is moved. We could type var m event equals E as an input event mouse motion. And so you can see this is called casting. We're changing E into this type because we already know that it's that type. And so now we can use this to get all of the juicy information from the type. The reason that it's sent as an input event is because that way, whatever value it is still considered an input event, and it can be sent over this way, instead of needing a separate method for every different type of input event. And then all we have to do is just cast it back to its original form, and we have all the information we wanted. So now m event dot relative, if it'll load, that relative is the value we want. It is the relative mouse position from the previous position. And so it doesn't matter for our purposes where the mouse is on the screen, it matters that it moved. And so even though the mouse may be in the upper left-hand corner of the screen, if we've moved to the point that the player should be facing downwards, we want the player facing downwards. And so this is a way we can use the relative position. And that's a vector 2. And so motion is going to be the mouse event relative. And now we're going to want to apply some transformations onto this vector. And we're likely going to want those to be export variables. For example, an export mouse sensitivity. And you can even set up a property range to make sliding this easier. This will affect how much it affects the movement. And while we're up here in the ready function, which is called when we start, we're going to want to go to the input singleton and have mouse We want to set mouse mode equal to the input dot mouse mode enum dot captured. And what that means is it locks the mouse into the window. And so it hides the mouse, like you see with a lot of first-person games. And then all of the translations will happen without the player seeing them. And so however we handle them down here is all the player will see. Because we're setting it to captured, we also won't be able to use the mouse anywhere else. And so it's helpful to also say in the events, if E.is is action pressed. You can also do release. Is action pressed and we're going to have UI cancel. And so this will check if the event is a specific input action, because there's different input events depending on the input type, such as a keyboard, a mouse, a gamepad controller, or whatever. And this is just to check, is it that input action? And what we can do is we can say mouse mode is equal to, and we're going to use something called a ternary operator, which is like setting up an if statement, but right here. And so we'll say input mouse mode, two equal signs to check if its value is equal to that. Mouse mode enum dot captured, put a question mark. So if this is true, we want the value to be input dot mouse mode enum dot visible, which is the default mouse that you can see and move around. Put a colon, and if this is false, which means that it's not captured, we want to make it captured. And because this is using the input event, this will act as if we were using input.justPressed in the process function. And so when the action is first pressed, which is UI cancel, it'll check if the mouse mode is captured. If it is captured, we'll set it to be visible, and if it's not captured, we'll set it to captured. This will let us toggle the mouse in and out. So now another useful thing that we're going to want to do is we're going to use two ampersands for the and. We're going to do input, and we can actually just copy it from here. If the input is captured, then we'll move. Otherwise, we want to not move when it's not captured. That way, if it's set up so that you have a user interface, like an inventory or some menus, the player's view won't be running everywhere and showing all kinds of random things while you're moving around the UI. So now, because we have our mouse sensitivity, we'll go in here and we'll have event.relative times mouse sensitivity. And the vectors are set up just like regular vectors, and so when you apply a scalar, it'll apply to each individual component as opposed to changing it in some way. So now we have our transform that motion.y times equals -1 f. What that'll do is that'll invert against the standard way for motion.y. And that's more comfortable for me. That's how I prefer to have my controllers. We can have this as a setting later on, which will allow the user to choose which way they want to move the mouse to move the head up and down. Now, we want to rotate something. And if you remember from last episode, in the character controller, we can jump there here, or by going here and jump here. We have our camera rig, the Y rotation, and then the camera. Now, these names are important, and one thing we're going to do is we can go in here, and we can go down and copy node path, or Control-Shift-C. We're going to copy that to the clipboard real quick, go into our code, and now at the very top, what we're going to want is a private camera. Set it to a null, because we don't have it right now. And now, if you're familiar with Unity, there's a very similar system to the get component in Unity. And so what we can do is we can do get node, and we give it path. And you can see you can also add typing, so you can specify the return type, which we know is a camera. And if the path is wrong, or it's not the type that you determine, this will return null. And so we'll give it camera is equal to that. And so if this fails, camera would still be equal to null, and anywhere else we use camera will fail and give us an error, and then we can fix that error. Now we're also going to want a private spatial camera y equals null. The camera y is going to be equal to get node spatial. And now we have the same path, and we just want the node above. And so you can see it's camera rig, y rotation, camera, which is the same organization as in our scene tree. And so to go from a parent to its child, we're separating it with a slash, and it starts with the first node, which you can see is a direct child of the root node. And so it's a relative path is what it's called. You can also use an absolute path if you want. That can change a lot based on how you have the scene structured. And so generally, if you're using an absolute path, you want to be getting the absolute path in the code. All kinds of errors can be introduced with paths, so be sure to check that you're using them correctly. Now, sometimes, and it doesn't always work for me, I'll get autocomplete for the paths. It doesn't like it when you fill out the template type first. And so usually what I'll do is I'll type get node, I'll use the autocomplete to get the path I want. Then I go back and give it the type I want. Then I end it with a semicolon, and then I assign it to the variable. It's a lot more than the easy on-ready nodes of GDScript, but we have the speed, performance, and static typing of C#. And so we know this is a camera. Okay, and so now we have the camera and the camera Y stored in these member variables, so we can access them in any of the methods down here. For example, when we get the mouse motion, we can actually apply some rotations. So now what we want to do, we have motion.y, we're going to have camera y dot rotate, and you can see there's a couple options. Rotate, you have to give it an axis. We can just say rotate y, motion.y. Camera dot rotate x, motion.x. And so this will happen for every movement input from the mouse. So we can go back to our project, hit play, and you can notice my mouse just disappeared because now we can move. And as you can see, it's moving very quickly, very randomly. And we can hit escape key is the control to toggle. And when it's toggled, it doesn't move. So you can see we're moving very, very, very fast. So what we need to do is go back into the code. We're going to change our mouse sensitivity. I'm going to show you the extreme. And so something interesting is here I am moving my mouse from left to right. And then up and down. But up and down is moving it from left to right, and side to side is moving it from up and down. The reason this is because the axes are different between 2D and 3D. You can see on the camera, this is the y-axis, the green. Y-axis actually moves for visuals on the x-axis. And on the x-axis is moving the visuals on the y-axis. And so what this means is we need to actually flip which values we're using. And so we'll go back in here. You see, we were inverting the y, but we need to invert the x now, because that is going to be the up and down. And we're going to rotate y by x, and rotate x by y. It's a little confusing. Hopefully my example shows you why we're doing this. So now if we go back, I move from right to left, and we have up and down. And so this visual input is going to be an inverted y axis. And so for me, I want to actually flip. And so because we're rotating on the x-axis to get the y motion, we're going to choose to invert the y-axis. We'll multiply this by negative 1.0. We have to put an f there to tell it it's a float. Now we'll run this. And now moving the mouse up, looks up. Moving the mouse down, looks down. And left moves to the right, and right moves to the left. And so because of that, we're going to want to multiply x by negative 1 as well. And so because we're multiplying both elements by negative 1, we can actually multiply it by negative 1 again. And remove these here. And so now it's the vector times the scalar, inverted, and then we rotate by that. And so let's test that in here. And so right moves right, left moves left, up and down. Beautiful. And let's walk forwards. You see we move on the same axes as before, but now we can look around. But we're not moving in the direction we're facing. We're moving strictly on the axis that is defined. We press F8 to close that out quick. This is because our target acceleration is the hard axes, the X and Z axis. And so the character controller is only moving on, as you can see, the X and the Z axis. Now, we want relative axes. What that means is that the local space based on the rotation is what we want to use. Specifically, we want the camera's local rotations, which will point at exactly where the character is facing. Now, if you're familiar with Unity, you're probably looking for something like transform forward. That doesn't actually exist in Godot, at least not yet. It might in a future version. What we're going to do is we're going to have the forwards, so var forward is going to be equal to camera dot global transform dot basis dot z. And we're going to have that negative, because remember, the negative z is what is forwards. And so that right there is going to be a vector 3 of the forwards axis. We're also going to have var right, which is the positive x basis, be camera dot global transform dot basis dot x. And so now we have the input x times speed. Because this is now the forward vector, a positive input will move forwards, and a negative will move as the inverse, as negative. So we can remove the negative from this, and we can have forward multiplied by the input multiplied by the speed. And that's giving us an error, because instead of assigning it to the z-axis, we actually want to add this to the entire velocity. And so what this will do is this will specifically choose a forwards axis based on where the mouse is facing. And so we'll add as well right times input.x times speed. So we'll save that, and let's run it real quick. We can move around, we can press forwards and move that way, forwards and move that way. And you can see we can move relative to where we're facing. Now, if we look down, you can see we're actually flying. And so we can move however we like. Which, if you want to make a fly cam mode, this is exactly what you would want to do. But let's hit F8 real quick, because right now I want a character that stays on the ground. So what we need to do is set target velocity dot y with 0.0. And so now what that will do is that'll make sure that we're not moving on the y-axis. As you can see, no matter how much up or down we look, we're not going to move up or down. But as you can see, we actually move a lot faster looking forwards than if we look down or if we look up. The reason this is because all we're doing is setting the y to 0. And so if we want to maintain a standard speed, what we actually want to do is use target velocity normalized. And that doesn't set the vector, it actually returns it. So we need to say target velocity is equal to itself dot normalized, semicolon at the end. And that will basically divide it by its length to make sure it's at most 1 for a length. Because we're normalizing it, we're actually going to lose the speed. So instead, we're going to remove that from there and let this calculation step here just be getting it to the desired direction. And here we can multiply by the speed so that now, at most, the player will move the speed that we set in this export variable. So now if we save, we go back and run, we can look around, and if we look down, you can see we move just as fast as if we're looking straight ahead. And so this is going to be really helpful, especially if you're making a first-person shooter game, because if the player is looking down, like down a cliff at someone lower, you don't want them to be forced to move slower just because they're looking downwards. Especially if you're making a game similar to Halo, specifically the older titles, they had a normalized speed and then crouching would move slower. And so this will make sure that you're always using max speed. You can do an extra check to see if the target velocity is going to be greater than 1 and then normalize it that way, because otherwise when you have something that's less motion, it'll always be the max speed. But if you check to see if it's over 1.0 length first and then normalize it if it is, that'll make sure that you can have small motion if desired, but max speed at a certain threshold. And you can reduce the length that you check against to determine the threshold for maximum speed. So if you are a Unity developer, you may be thinking, wow, I really don't like how this looks. This is kind of a pain to write out every time. If you really do want a transform.forward option, we can use the design by composition principle to make a class that parses the transformation and gives us back some helper values. And so what we can do is we can go into our modules, we can make a new folder, and we're going to call it transform. So now we're going to make a new C# class. We're going to call it fun transform. Or better yet, call it uTransform, which is going to stand for the Unity transform. And so now in the namespace, I'm just going to change it to transform for the namespace. Now we're going to have a private member variable of transform. And you can see this doesn't exist yet because we actually need to have the using Godot declaration up here. Now we'll make a constructor public uTransform transform. And so this dot transform to n form. And now, when this is created, we'll have the member variable. So we can use some properties that C# allows us to make that'll access information from the member variable. We're going to have a public vector3. And we're going to call it forward and we're going to have a get, which is going to return the negative transform dot basis dot z. And we can do the same thing to 3 right get turn transform dot basis dot x public 3 up turn dot basis dot y. And so what this does is this will allow us to access these variables and not this variable. And these variables only have a get. We could have a set as well, but we don't want to be able to assign it. We only want to get the values. And so now we're going to have to use transform. Using transform. And I like my namespaces to be lowercase, similar to the way that I'm naming them in the modules folder. And that'll also help differentiate that this is something I made versus something that is made by Godot or C#. Now, when we're using the camera global transform, we could have a var utrans, which is going to be equal to a new utransform. See, it wants a transform, so we're going to take the camera global transform, initialize it there. And so instead of forward and right, you can just use utrans dot right and utrans dot forwards. Trans is a commonly shorthand word for transform, which we'll use a lot in game engines in general, so that's a good one to know. And so that is a little helper class, and that exists now, and we can keep using it whenever we want to get relational transforms, relational directions off of a transform. And so that might be useful for other systems as well. Right now it's really helpful to get where the right direction is and where the forward direction is. And so if you're new to working with game engines or working in spatial transformations in 3D space, transform might be a new concept. Basically, a transform is a way to encapsulate a 3x4 matrix of information. If you look into lower level graphics programming, you might be familiar with things like the model matrix or the view matrix. And so you can think of the transform as kind of a combination of the translation, rotation, and scaling needed to get the node to be where you desire for it to be in 3D space. For example, if we go onto this transform, you can see there is translated. There's the origin, which is the current position of it in local space. You can have rotated and scaled. And so those are the main functions of transform that we can manipulate to change the way that a 3D object is interpreted. As opposed to in 2D, where you generally have the position, rotation, and scaling as a 2D and then two regular float values. In 3D, the position is going to be a vector 3, the rotation is also going to be a vector 3, and the scaling is also going to be a vector 3. And so you get all of those in one with the transform. And then there's helper functions to manipulate them, like in rotate Y. Now, at this point, we've written a lot of code. It might be good to kind of clean it up. And so we've already done a little bit where instead of using what are called magic numbers, we replaced our acceleration with a variable, which tells us what it is. It's the target acceleration, and we have all of these. These comments are built in from Godot. I'm actually going to delete them because they describe in general what the method is for, but not how we're using it. And so what would be more helpful is to add some comments to describe what is where and why it's doing. So these are our export variables. Internal member, scene3 members. And I like to separate the actual member variables versus accessing the scene tree variables, because these we have to be extra sure to initialize in the ready function with a get node call, or to initialize it somewhere else when we need it. And so I'm going to be a little bit more verbose in my commenting than I normally would in a personal project, because I want to help make sure that everything is very clearly understandable for someone trying to learn. And so you can view this code on the GitHub repository if you need to take your time with it. But I'm just going to run through and add comments. Alright, so I added quite a few comments. As always, 2 slashes means that it starts a comment, and that means that this is something that is describing what's happening, and so when the code's running, it just ignores it. And if you want to make a longer comment, you can have /star or asterisk. And so this one starts it, and this one stops it, and you can have as many lines as you want. And outside of it, it won't be there. And so you can even move that, and we can now comment out that whole function, and that means it won't run. But we don't want that, so what we're going to do is we're going to get rid of it. And now, this is pretty much everything we wanted for this character controller right now. All the comments are in, all the calculations are happening. If we go into our project here, we can see that we can look around as we like, and we can move as we like as well. And so we can move, and it's always going to be relative to where we're looking. So if you just hold forward and move the mouse, it'll change. It stays at a standard speed, no matter if you're looking up or down, thanks to our changes we make to the vectors. And it should be working exactly as this for you. We don't have any jumping, we don't have any crouching. Right now it's just moving and the relational stuff. And it should be helpful that we've made that helper class to translate the transform variables into more meaningful names such as up, right, and forward. And we can use those later on for other calculations. Alright, thank you so much for watching. I hope this character controller is much closer to what you want for your game. In the next episode, we're going to be working on adding sprinting and jumping. That is, unless you did the homework in episode 2, then all you'll be doing is adding jumping. Homework for this episode is going to be practicing reformatting your code. Make sure you're getting rid of magic numbers, and try to add comments that'll help you understand what the code is. The goal of any commenting scheme is always to make sure that the code is understandable enough that you can give it to someone else who doesn't know what your project is, and they can understand what's happening, or at least what you're trying to do. Especially in the case where you have an error or a bug, but then they can help you. Stack Overflow is a wonderful place for those kinds of things. Big shout out to my supporters on Ko-fi. I am only able to do this series because of their support. So I've got a big thank you to my supporters Noel and Miguel. Thank you so much for your support. If you want to join the ranks of my members on Ko-fi, it's only $1, and you get to see all of my episodes as early as I finish making them. Thank you so much for watching. Have a great day.